Continuing section 1.2, levels of measurements. There is another way that we can use to classify or to separate data into different types. And today we're going to discuss this classification level of measurements. And we're going to divide our data that can be collected from sample into 4 levels. The first one is called the nominal level. And the at the nominal level, we're talking about data that is categorical or qualitative. Nominal level, we have qualitative data. Such as, for example, names, names of individuals, city, the city that the individual lives in. For example, the type of car that the individual owns, eye color, driver license number. This is a number, but it is not a measurement. It is not counting anything or measuring anything. So the driver license number or identification number or the social security number is, all of these numbers are for identification. So this data is still at the nominal level. No measurements or counts of anything. So this is the first level, the lowest level, which is the nominal level, names and labels. We're talking about qualitative data. The second level is the ordinal level. And the ordinal level, data values can be arranged in order. So there is some type of ordering that you can apply. You can sort your data from lowest to highest, best to worst, and so on. So there is a type of ordering that can be applied to the data. So that's why we call it data at the ordinal level. But at this level, the difference or differences between data values is meaningless, or the differences are meaningless. Do not make sense to take the difference. So for example, let me explain. If you have, let's say, letter grades, let's say the grades that I gave last semester to one of my classes, let's say assume that these are the grades that I gave. B, B, A, C, D, A, B, C, C, F. All right, so this is let's say sample of letter grades. Now this sample or this data, sample data, is at the ordinal level. Reason this is the ordinal level because I can arrange these letter grades in order from best grade to the, or the highest grade to the lowest grade. So I can start with A, so I have 2 A's, I have then 3 B's, I have 3 C's, 1 D, and 1 F. Right? So I arranged my data in order. So that means my data, sample data that I have are in the ordinal level. Now, it doesn't make sense to subtract A minus B. That doesn't make sense. There is no use for that. It's not going to help you do anything with the difference. The differences does not mean anything. Okay, so the difference is meaningless. All right, so that's the second level. And the third level, we have data at the interval level. Interval level. In this case, data values can be arranged in order. And the differences of data values are useful. Data values can be the difference between data values are useful. It can be used in the statistical analysis to learn or obtain more information about our data, sample data, and understand our sample. So we can use the differences. Like, for example, guys, temperature. Let's say I'm going to collect sample data on temperature for the last few days. Let's say 3 days ago, the temperature was, let's say, 76 degrees Fahrenheit. The day before, after yesterday, let's say 80 degrees. Today is, let's say, for example, 74 degrees. Right? So we have these measurements, temperature measurements. I can arrange my measurements in order. I'm going to say 74 degrees first, and then 76 degrees, and then 80. So now it is in order. And also, I can subtract, let's say today's 74. Yesterday was 76. I subtract, I get -2 degrees, -2. This is the difference between today and yesterday. That difference can be used in statistical calculations. It is okay. It's useful. It can be used in our calculations. The differences between data values. However, at this level, there is no natural zero. All right, there is no natural zero. What does that mean? It means that when I say 0 degrees Fahrenheit, that doesn't mean there is no temperature. It doesn't mean the absence of temperature on that day. 0 is like any other measurement. It is not a starting point. It is not, there are some temperatures that are below 0, after 0. So this is not a reference. 0, in this case, does not mean the absence of temperature. Okay. So at this level, guys, our data, when at the interval level, we do not have a natural 0, or 0 is not considered a starting point. Now, the next level, the highest level, is the ratio level. At the ratio level, we have all the characteristics of the interval level with the natural 0, including the natural 0. So data can be ordered. Differences are meaningful, very useful to do the differences. And there is a natural 0. Yes, I have a comment from Matt. So 0 degrees, is it? Yes, you're right. 0 degrees is an actual temperature. It does not mean that at all. So, guys, can you hear me? I'm sorry, somehow
yes.
We lost the screen. Let me go back to Zoom again. So yes, and this at the temperature level or the interval level, there is no natural 0, but at the ratio level, we have a natural 0. So for example, when I talk about distance between 2 points, like a distance a student takes from home to college, distance between home and college, that distance can be arranged in order. Some people just live like 2 miles away from college. Some of them far away, 5 miles, 6 miles. So some of you guys live right next to the college, 0 miles. So when I say 0 miles, 0 mile, that means no distance. So the 0 in this case is natural. 0 means the absence of that quantity. It means the absence. So when I take measurements, usually measurements like, for example, distance, volume, height, all of these are considered measurements or data at the ratio level. Okay, so heights, length, distances, all of that, all these types of measurements are considered a ratio level. Okay. All right. Any questions? The next thing I want to talk about in this section is actually, guys, no, I'm done with this section. This is all what I need to say about this section. I'd like to move on to section 1.3, collecting sample data. So when you use statistics in a study, planning is very important. It is essential to use an appropriate scientific sampling method for collecting data, to collect data. And in this section, we're going to talk about the different methods that we can use to collect sample data. Remember, the goal is to get information about the population, and this information can be obtained by sampling. And there are different ways of sampling and getting sample data. So we're going to talk about these methods, and then we're going to talk about other related concepts. Question from Sierra: will the test have more than what you went over? No, as I said, the test is based on my lectures and based on my homework assignments. So if you don't see anything, if you don't see a concept in the homework or in the lecture, you can skip it. There's a lot of details, a lot of the things that are discussed in each section, and it is impossible for us to cover completely everything in the section. So, especially because this is a summer class, I'm not going to be able to cover a lot of details in each section. So I'm going to talk about just the main concepts for each, the things that the most important things that you need to know in each section, and you will be tested on that. Okay. So yes, so collecting sample data, that's our concern right now. We want to discuss first, number one, we have two types of statistical studies. We have observational study, and in the observational study, basically we observe and measure specific characteristics of the individual. We collect measurements. So the researcher observes and measures specific characteristics of the individual. To be more specific, of a randomly selected individual. So the researcher, the person who is conducting the study, collects data by observing, by measuring specific characteristics of the individual. There is no application of any treatment here, no treatment being applied to the individual. This is called an observational study. The other type of study we have is the experimental study. Experimental study. In an experiment, what happens, the researcher applies some treatment and then continues to observe the effect of the treatment on the individual. These types of studies are usually done when there is a new medicine in the market, a new drug, a new method, something new that is coming out to the public. So the manufacturer, the company that has this product usually want to test that product before it markets, put it in the market. So they usually conduct experimental studies. So the researcher applies some treatment and then measures the effect on the individual. Okay. And there's a lot of details with experimental studies, a lot of terminology, a lot of different types of experiments. We're not going to go deep into this area. There's a whole, chapter on different types and terminology and ways to conduct statistical experiments. So we're just going to skip that. We just need to know that we have these two types of experimental studies. So we're not going to go into the design of the experiment. Okay. Also, we're not going to go into the details about observational studies. When you discuss observational studies, we have, again, different types. We have the retrospective, we have the cross-sectional, the prospective. Those also are details that we're not going to go into in this summer session. Okay. All right. Now we're going to go into the next important concept, which is the different sampling methods we have or we can use to collect sample data. Okay. So sampling methods. Guys, are you with me? Can you please type yes? Can you hear me well? All right, excellent. Thank you. Appreciate it. All right, so sampling methods. We have different ways of we use to select sample data. And we're going to begin with the what we call the systematic sampling. Okay, so number one, systematic sampling. Now, in a systematic sampling, the researcher selects a starting point and then selects every, let's say, for example, every fourth or fifth individual in the population. So the idea here is just not the fourth or the fifth. The idea here is that there is a system, a way, a pattern that is used to select the sample. There is a pattern. So for example, the researcher will give a number to every individual in the population, and then the researcher decides, okay, I'm gonna start with the third or the fourth person, and then I'm gonna select every, skip 3 individuals and go to the, let's say here, say fourth, go to the 7th, the next one is the 10th individual, the 13th individual. So there is a pattern that the researcher is using to select his individuals. It's not random. It's opposite to random. It is a systematic sampling. There is a system or a pattern that is used to select the sample. Guys, opposite to systematic sampling, we have the opposite to that, which is random sampling, which is the most effective way of collecting data, random sampling. Exactly the opposite of systematic. No pattern here. A random sample is selected in such a way every individual in the population has a chance, an equal chance of being selected. Every individual has an equal chance of being selected. No pattern in selecting participants or individuals. Stick to the word individual. And every individual has an equal chance of being selected. Okay, so the researcher will give each individual a number, and then will take, maybe the researcher will use a computer program to randomly select some of these numbers, and these individuals will be selected, and they form a completely simple random sample. Okay, so that's random sampling. it is intuitive, you know, it's just completely random, no pattern or no system in this selection. Number 3, we have other ways of sampling, which is a combination of systematic and random that involves both. This one I'm going to discuss now is called stratified sampling. Stratified sampling. Okay. So it has a pattern. Part of it is systematic, the other part is random. So this is what happens. The researcher divides the population into at least 2 groups so that the individuals within the same group have the same characteristics, or they have a common characteristic. Right? And then after dividing the population into groups, then the researcher selects few individuals from each group. Okay, selects few individuals from each group. Let me explain with a simple diagram here. So here's, guys, our population. Let's assume that this oval here is our entire group of individuals that we are studying, the population. What happens, the researcher will divide this group into this population into 2 groups, let's say females, males, based on gender. Use the gender category or the age, whatever category the researcher decides. He divides the population into, let's say, these 2 groups, and then from each group he selects randomly few individuals. Okay, and let's say he selects, for example, 3 males and 4 females and put them together and becomes the sample. Right, so these individuals form that are randomly selected. The 4 females, 3 males will go into the sample, and then he will collect sample data. The researcher will collect sample data. All right, so few from each group. This is called stratified sampling because he, used a category to divide the population and then randomly select few from each group. So this is not random sampling, not simple random sampling. This is called stratified sampling. Okay. Number 4, Another type of sampling is called the cluster sampling. Cluster sampling. In a cluster sampling, the researcher divides the population into sections or clusters. Okay. Then he randomly selects some of these sections, right? So he's going to take few sections, complete sections. Some of these sections, he randomly selects some of these sections and selects all the individuals in those selected cluster sections. Okay. Again, let me explain with a simple diagram here. Again, this is my population. What happens? The population is divided into sections, clusters. Cluster 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And then randomly we select some sections, like section 1, section 4, section 7, and then we put all the individuals in these selected sections together, and these three sections become the sample. Together, everybody in every individual in these selected clusters become part of the sample. They become, these three sections become our sample, and we collect data from these sections only. Okay, so these are the other types. Cluster sampling, stratified sampling involves, a pattern. You divide the population, and then you select, so they are not considered completely random. Most of the statistical methods that we gonna discuss in the future require us to assume or make the assumption that the sample is a simple random sample. No pattern, no category used to select the sample. Okay. All right, guys, these are the 4 types of sampling methods that I want to discuss. The book talks about other methods like convenience sampling. Convenience sampling is, of course, is a non-scientific sampling method. Convenience means that you, when you collect data, you give the survey to your relatives, to your friends, to your brothers and sisters. So convenience, the sample that you get does not represent the population. This is called convenience sampling that will give us a biased sample. Are you with me, guys, please? Yes. Excellent. Thank you. All right, so I'm done with chapter 1. These are the main things that I want you to know in this chapter. I assigned the homework on this chapter, so you should be able to do the homework now. Any questions on the homework, guys? Where you did you already start working on it? Please start as soon as you can, because you need to submit your assignments on Thursday. All right, I'd like to begin the discussion on chapter 2. I need the PDF version of the book. Did you order it, Eddie? Did you order the PDF version? From which, from Pearson? Or from some, oh, Amazon, okay, yes. Thank you. All right, guys. So focus with me on this topic here, section 2.1. So guys, here's the thing. Most of the time, when you collect sample data, the sample you have must represent the population. And sometimes the population is a very, very large set of individuals. And based on that, the sample is going to be also a large sample. So you're going to be collecting a large data set. So in this case, you will learn more about your data if you organize and summarize your data into tables, and you look at the distribution of the data. So this is what we're going to discuss in this section. We're going to talk about frequency distribution, frequency distributions for organizing and summarizing data. You need to organize and summarize data. All right, so we're going to talk about the first item in this section we're going to talk about is frequency distribution. A frequency distribution or sometimes I will use the word table. A frequency table shows how data are partitioned into several classes or groups. We usually use the word classes. By listing the class along with the frequency of data values in each class. So listing the class with the frequency of data value in each class. Okay. Guys, let me explain this with a very simple frequency table. Look at this table. Okay. Test scores. Let's assume, guys, I collected a sample of test scores, a sample from one of the sections that I taught let's say last semester. I selected few test scores. I got the test scores and I summarized them in this table here. Test scores and frequency. And let's say 60 to 69, 70 to 79, 80 to 89, 90 to 99. Okay, so let's see here. This is my first class, or class number 1, class number 2. So I divided my test scores into 4 classes. So here I have 4 classes or groups, and for each class there is a frequency, which means the number of values within each class. So let's say here 4. In the second class, let's say 10. The next one, let's say 5. The next one is 3. So each class has a frequency, correct, partitioned, each class, which is a subset of these from the sample, and each class has a frequency. So I have here 4 values. For example, I have 4 values between or from 60 to 69. Okay. The second class is from 70 to 79. And we have 10 values within this range, and so on. Now, if you take one class, let's say the 70 to 79, the first number that you have here, this is called the lower class limit. Lower class limit. The beginning of each class is called the lower class limit. I have a question here from Mia. What does the word say after R? Which one? Oh, R, partitioned. Partitioned. Sorry about that. Let me fix it. All right, so we go back to this class here. It has a lower limit and has an upper limit. Upper class limit. Okay, it has a beginning, it has an end. It begins, so if you have a test score that is 70, 70 will go into this class. 79 will go into this class. all the way from 70 to 79. Also, we have what we call class width. Now we have to be careful, guys, with class width. The class width is the difference between two consecutive classes, the difference between two consecutive class limits. The difference between two consecutive lower class limits. Okay, so if I go back to the table, look guys at this here. This is the 60, the beginning of the first class. The beginning of the next one is 70. The difference between these is what? Is 10. This is our class width. So class width in this case is 70 minus 60, which is 10. Right? So no matter what class limits you take, lower class limits, the difference is always the same. 60, 70, 80, 90. If you look at the difference, you see that the difference is 10. Also, if you compare upper limits, 69, 79, 89, you're going up by 10. It's always the same. So that's your class width. Okay. So we have lower limits, upper limits, we have class width. We also have something called the class midpoint. These things that you need to know, guys, about frequency distribution or frequency tables. Okay, class midpoint. This is what you do. Let's say your first class is from 60 to 69. How do you find the class midpoint? You take the lower limit, you add it to the upper limit, and then you divide by 2. Midpoint. So that will give me 64.5. Make sense?
I have a question.
Lower plus upper divided by 2. I have a question. Yes, go ahead.
So for the upper class limit and the lower class limit, is it only pertaining to the 70 through 79, or can the upper class limit be like 89 and then the lower class limit be 80? Were you just
yes, each class has its own limits.
Okay.
So let's say this class here, third one, the lower limit is 80, the upper limit is 89.
Okay, thank you.
Yes, no problem. So guys, if you focus on one class and if you look at the limits, you take the upper limit and the lower limit, you add them, you divide by 2, you get your class midpoint. And each class has its midpoint. So what are the class midpoints that I have in this table? What do I have? I have the 64.5. That's the midpoint of the first one, the first class. What is the midpoint for the next class? It is what? 74.5. Halfway between 70 and 79. What is the next midpoint? The next midpoint is 84.5. The next one, 94.5, and so on. Again, you can see the difference is always 10. You're going up by 10. When you go from one midpoint to the next one, you're going up by 10. Right? So these are class midpoints. Also, What if you want to find class boundaries? Class boundaries. What does that mean? Guys, look again at the table. Focus with me on the table. You guys, if you look at the first class, actually, let me write it here. The first class begins with 60, it goes to 69. The next one from 70 to 79. Now there is a gap between these, right? There's a gap here. The first one ends at 69, the other one, the next one begins at 70. So there is a gap. Now, what is the number in the middle of the gap? What is halfway between 69 and 70? That's 69.5, right? So my first class boundary is the number between the first and the second class, which is 69.5. What is the next one between the second and the third? 79.5. The next one, 89.5, right? And then the next one, 99.5. These are the numbers exactly between, halfway between the classes, not inside the classes. They're outside. These numbers are outside, but they are, separating the classes. Okay, so these are called class boundaries. Any questions? So class boundaries are the numbers used to separate the classes. All right, so this is one thing I wanted to mention, talk about, the different things that we need to see and understand in a frequency distribution. All right, so this is one thing. The other thing, guys, here is this. When you look at the second column, the frequency column, this column here, look at these numbers. What do we notice? We notice that the frequency is low, relatively low, right? Starts with 4. And then it goes up to 10. It increases, gets higher, and then it drops down again. Okay? So if you look, guys, you can see that we have something like this here. I'm gonna draw a curve that represents the pattern that I see here. The frequency is low, it goes up to a maximum value and drops down to a low value again. Okay, so this curve appears a lot in sample data. This curve that you see here, where the table begins with very small values, small frequency values, and it goes up, 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 and then goes down again. It gives us what we call here a bell curve. Now, this bell curve has a mathematical term. We call it normal distribution. This bell curve represents a mathematical curve, and we call that curve normal curve or normal distribution. Okay. normal distribution. Let me more clear here. Distribution. Or normal curve. Okay. So, of course, when you have more than 4 classes, when you have a table with 5 or 10 or 15 classes, you will be able to see this curve very clearly. You will be able to see the data going, the frequency going up and then going down and giving you a bell curve. Right? A lot of sample data, a lot of analysis, statistical analysis is based on bell curve. Any questions, guys?
Professor, I had a quick question about the class boundaries.
Absolutely, yes.
Is that only with the previous upper class limit and next class lower limit, the boundary between those two?
Excellent, yes, correct. Between the upper, the previous one, and the next one lower. Yes.
Okay, thank you.
Yes. This is my first one upper, and this is my next one lower. In the middle.
Okay.
Okay. So what else? I talked about class boundaries, class midpoints, lower class limits, upper class limits, class width. Okay. Now the next thing I want to show you is how to construct your own frequency table. This one I gave you is already given, is already partitioned, everything is done for you. But what if you want to have your own class, want to have your own frequency distribution? Look at this example here. Construct a frequency distribution for the following data set, or for the following sample data. Use the following: lower limit of first class is 5, class width is 3. So it gives you guidelines. It tells you that you want to construct, the example telling you to construct a table, a frequency distribution with these properties. We want the class width to be 3, and we want to start the distribution with 5. The first class begins with 5. Here's the sample data. Six.
Is there any way you can explain where the 5 and the 3 came again?
Absolutely, yes. Those are usually given. Those are given in the, when you're asked to construct a frequency table, you are given some values so that we can all get exactly the same table. If I leave those numbers up to you, then each one of us will come up with a different table. So I'm putting a guideline here on constructing the table. Guidelines, I want the table to begin with 5, and I want the class limit, the class width to be 3. So these will be given.
Okay, thank you.
Yes. So guys, this is our data set. We're gonna now convert it to a table with these guidelines here, with the lower limit of the first class is 5, the class width is 3. So look, this is what I'm gonna do. Okay. So let's assume that these values here let's call these hours of study per week. Let's say that these are number of hours collected from students. These are the numbers of hours a student study per week. So here I'm going to label this first column, hours. And here I'm going to put frequency. Okay. Now, look, guys, what does it say? It says begin with 5. The lower limit of first class is 5. So I'm going to put 5. And then I'm going to go and look at the class width, which is 3. And then I'm going to add 5 plus 3 is what? 8. So my next class begins at 8. 8 plus 3, 11. 11 plus 3, 14. These are my lower limits. Now, what are my upper limits? 5 to what? Well, since the next one starts at 8, so that means 5 to 7. Seven to, what do you guys think? 7 to 10. 11 to 13. See how consistent? 5 plus 3 is 8. 8 plus 3 is 11. Class width is 3. And then the upper limit, 7, 10, 13. Do I need the 14, guys? I don't see, or actually I do see 16 here. So I need one more class, 14 to 16. So all I need is 4 classes to organize my table. 4 classes. The first class from 5 to 7. Next one, 8 to 10, 11 to 13, 14 to 16. Make sense? We have to be careful, guys, when we construct our table. You have to use the numbers that are stated in the problem. No, we cannot. We have a question from Brandon. We cannot do 5 to 8 because if I do 5 to 8, then my next class is going to be what? 9 to 12? And that's not correct because 5 and then the next one is 9. The difference is 4. And in this case, the class width is 4, but we want the class width to be 3. The difference, which is the class width, is 4, which is not correct. We want the class width to be 3. Okay, so 5, and then the next lower limit is 8, the next lower limit is 11, 14, and so on. All right, so once you partition your data correctly into classes based on what is given, then you go ahead and start finding the frequencies of each, the frequency of each class. So 5 to 7, 5 to 7, 1, 2, 3, 4, 5, 6, 6, 6, 6. Yeah, that's it. 6 values from 5 to 7. Again, 1, 2, 3, 4, 5, 6. Okay. Next class, 8 to 10. 1, 2, 3, 4, 5, 6, 7, 8. And then 11 to 13. 1, 2, 3. And then 14. Oh, I'm sorry, there is another one here I missed. 4. And then from 14 to 16, I have only one value, the 16, so one value. And I'm done. This is how I organize my data based on class width of 3 and beginning table that begins with 5. Lower class limit is 5. Okay. All right, guys, excellent. So the next thing I want to discuss what you see here, this is called a frequency distribution. Now I'm going to show you how to construct a relative frequency distribution.
Professor, for that example, with those numbers in that parameter, were those just random numbers or?
Oh, those will be given. This is sample data. I give you this sample data. I give you the set and I give you the lower limit class width, and then you, based on that, you construct your table.
Okay, got it. Thank you.
Yeah. All right, excellent. Now, we're going to construct a table called a relative frequency table based on the table that we just did, the frequency table that we have. But it's a relative frequency. The key word here, guys, is relative. So let me show you what we're going to do. Here's again 2 columns. Hours, frequency, five to 7, 8 to 10, 11 to 13, 14 to 16. Now, I'm going to add one thing here, guys. Look, I'm going to add the word relative to the next column, relative frequency. And what I'm going to do is I'm going to take the frequency of each class. Let's say the first one, 6, and then I'm going to divide by the total. So let's add these numbers here. The total frequency here is what? The total number of values that we have. What is it? I have 14, 15, 19. Okay, I have 19 values. So I'm going to divide by 19. Now, when I divide, I'm going to get a decimal number. So let's go ahead and do this. 6 divided by 19. That will give me this decimal number, 0.31578, and so on. What I'm going to do, I'm going to change this to percent form. Remember, we talked about the percent form yesterday. So what I'm going to do, I'm going to move this decimal point 1, 2, place it to the right, and then round to the nearest tenth. So 31 point what? I have 57, that becomes 6. 31.6%. 31.6% of the data values are within the first class. The next class has 8 values out of 19. Let me clean up a little bit, guys, this here. The next class, 8 out of 19. 421, 05, and so on. In decimal, this is the decimal. In percent, it is 42.1%. And then the next class, I have 4 out of 19, which is 2105. Rounded to the nearest tenth of a percent is 21.1%. And the last one, I have only one value in the last class out of 19. And that gives me a percent 0.0526, which becomes 5.3%. Now, if your numbers are good, if your numbers are correct, then what is the total, guys, here? If I want to add these percentages, I should get what? If my percentages are good, I should get 100%. So let's check it. 31.6, 42.1, 21.1, and 5.3. I get 100.1%. Guys, this is fine. The 0.1% is just a round-off error because we rounded the percents. So if you get 100.1, 100.01, something, very close to 100, or 99.9, you're still good. You're still fine. Your numbers are good. This is just because of rounding. That's the 0.1 here is okay because we rounded. 0.1 is okay. But be careful. If you get 103%, 104%, 94%, this is wrong. You're way off from the 100, away from the 100. So something is incorrect about your percentages. Okay. So this is what we call a relative frequency table, and I use the percent form. I did not leave the numbers as decimals. I converted them to percents, and I rounded to the nearest 10th of a percent. Always round to the nearest 10th of a percent, to 1 decimal percent. Okay. Are you with me, guys? Can you please type yes? Excellent. Thank you. All right. After constructing a relative frequency distribution, there is another table that you also need to know about, which is called the cumulative frequency distribution. And this is the last thing we're going to discuss today. Cumulative frequency distribution. Let me explain. Let's go back to the frequency table that we constructed earlier. Let's copy it and put it down again here. Hours, frequency. Five to 7, 8 to 10, 11 to 13, and 14 to 16. And the frequencies are 6, 8, 4, and 1. Okay. All right. So this is what we're going to do. This is the original table, the frequency table. Now, this is not the table that we want. This is the original table, the frequency table. I want to construct now a cumulative frequency table. Again, I'm going to have 2 columns. Again, labeling the same thing, hours, and instead of frequency, I'm going to say cumulative frequency. And then I'm going to use the phrase less than. This is a standard, guys, here. It's not, my phrase is not up to you what to write. Here we're going to use this standard phrase less than. And then we're going to put the lower limit of the second class, not the first one, not the 5, the 8. We're going to say less than 8. Right? So you always start, when you do a cumulative frequency table, you start with the lower limit of the second class. Less than 8. How many values do I have less than 8? I have 6, which is the frequency of the first class. And then the next line, I will say what? Less than 11, the lower limit of the next class. Now, how many values do I have less than 11? Now I need to add. I need to add the frequency of the first class plus the frequency of the second one, which is 14. So this is called the cumulative frequency. And then the next one, next line, less than what? 14. So now I'm going to add the 6 plus the 8 plus the 4. That gives me 18. And then one more line, less than what? Less than 17. And I have all my data values are less than 17, so 19. And that's called the cumulative frequency. A question from Sierra, why less than 17 and not 16? Because of the pattern that we're using. Look, we're starting with less than 8. What is the number after the 8 if I want to keep this pattern? 11. Next one, 14. And then what is the next number after 14? If I use the same pattern, this should be what? 17. Right? I don't want to say 16, less than 16, because if I say less than 16, then I will not be able to count the one that I have here in the last class. So keep the same pattern, 8, 11, 14, 17, be consistent when you construct your cumulative frequency. To check your work at the end, you must have the total number of values. This is the total at the end. The total number of values that you have is 19. You have 19 values. Okay. All right. So I talked about cumulative frequency, relative frequency. Okay. Guys, I just want to emphasize one more thing before we conclude today, that those frequency tables that we're working on, okay, 2 columns, class and frequency. These are important because they give you an idea about the distribution of your data. When you see the frequency going again low, 2, 3, 7, 10, 7, 3, 2, what do we notice here, guys? If we look and see this pattern in the second column, what do you see? 2, 3, 7, 10, 7, 3, 2. So what happens here? If I draw the frequency distribution of my data, I will see this bell curve. You guys agree? Right? So this class in the middle here, this class has the highest frequency. The class in the middle has the highest frequency. The first class has the lowest frequency. The last one has also low frequency. So we have, again, a bell curve. If your frequency distribution shows this pattern, then this is a very, very important observation about your frequency distribution. This tells you that your data, sample data, is normally distributed, or it has a bell curve. And if your data has bell curve, then you can do a lot of statistical analysis on it. If your data is not normally distributed, if it does not have a bell curve, you are restricted about what mathematical methods you use to analyze your data. So bell curve is a very, very important characteristics that you, if you have, then it will simplify, it will make things easier for you to analyze.